All right, this is Algebra 2, 323 student notes number 3E. So if you're wondering how do we divide rational expressions, remember that just means two things, or a rational expression is just something written as a ratio or a fraction. Remember when we're dividing, we're going to flip the second fraction only and just multiply straight across. Now these are basically already factored. We don't need to, there's no pluses or minuses, so we don't need to factor at all. We might want to rewrite them out a little bit. We do want to keep in mind our restrictions. I'm going to put those at the bottom. And the reason I'm doing that now, number one, we don't need to factor anymore. And number two, anything that's ever in the denominator must be taken into account. Okay, anything that's ever in the denominator must be taken into account. So y is not allowed to equal 0. Okay, because if I had a 0 here, 3 times 0, 0, no good. If I had a 0 here, 0 squared times 4, 0, that's also no good. Okay, so far, y cannot equal 0. Then I said I'm going to break these down a little bit, and I'm going to make sure that I flip the second one to turn this into multiplication. When I break this one down, 15 is 3 times 5, x cubed is x. You don't have to do this, but sometimes it helps to see what things can be canceled when you lay them out all out like that. And again, I'm going to multiply and I'm going to flip. When I flip, the 4 goes to the top, so 2 times 2, y squared is y. 10 is 2 times 5. Oh, I see a 5 over here. Okay, so remember when we multiply, everything across the top, everything across the bottom can all get kind of jumbled up. It doesn't matter. So this 2 times 5 that represents 10 is okay. That came from the 10 here. X squared is x times x, and then there is a y. Okay, so what you're going to notice here is what I've brought down are some x's, so x also is not allowed to equal 0. Okay, x cannot equal 0. If I plugged in a 0 here, it would make the whole denominator 0 and go away. So I'm just making a bunch of giant ones, the 3's, the 5's. X's cancel in a 1-to-1, so for example, those can cancel, but there is still one x remaining. 2's cancel, but this 2 still remains. I do see 2 y's on the bottom and 2 on the top, so those actually all cancel out. So what is remaining on the top? I see one x and a 2. 2 times x is 2x. On the bottom, what is remaining? Nothing. Okay, if nothing remains on the bottom, that's just a 1. We need a placeholder. We can't have it as 0. So this whole thing, this crazy division problem, equals 2x, and x and y each cannot equal 0.